Okay, hi everyone. So, am I audible to all?
Yeah.
Okay,
Yes.
great. So, anyone who is newly joined today?
Yes, sir. I am Suresh.
Okay. Anyone else? Okay, so only one person. So, Suresh, my name is Shashank, and I'm gonna be instructor for your CCIE batch. And regarding me, I am triple CCIE and service provider, data center, and routing switching. And I'm gonna take the batch of CCNP, CCIE for network journey for our enterprise track. Okay. So yesterday we have discussed about the complete syllabus, what we are doing, what we cover, what all we have, and today we're gonna start with the topic. But before that, I want to show you guys the CCIE lab that we made and what all things related to technology we're gonna cover on it. Okay, and after that, I'm gonna start with the topic of today. So let me just share my screen first. Okay, guys. So before I starting, so I'm putting everyone on mute for next 10 minutes so that I will explain you the full topology and then we can discuss if you have any question. So backend team, can you please put everyone on mute? Okay. Okay. Okay, so this is our CCIE Enterprise version 1.0 lab topology on which we're gonna do the complete lab. So let me explain you all the bits, what are there in this complete lab topology. So starting from the middle bottom, we have a Zeta site, which is our main office site that we made. And here we're gonna do the switching. Okay, so here, if you see it here, let me, okay, so we're gonna do the switching section here. So here in switching, we're gonna see RSTP, then we're gonna see MSTP, which is multiple spanning tree protocol, rapid spanning tree protocol. Then we're gonna see our VTP configuration. We're gonna see there are double links if you see able to see it. So we're gonna do ether channel whole configuration in at advanced level here. We're gonna use FHRP. So first top redundancy protocols in which we have HSRP, VRRP, and GLBP. Okay, so these three protocols we're gonna see. Then security of switches, how we're gonna do the security configuration. So those all things we're gonna see in this module or in this main office. Then if you see here the sub block which is in purple, this is for your SD-WAN. So I have three controllers, which is vBond, vManage, and vSmart. So those are the controllers that gonna sit in our main office. And then they are connected to our SD-WAN site. So the site that we use for SD-WAN is on the top right. If you see this site, this is the Sigma site that we use for the SD-WAN. These are our SD-WAN V edges. Okay, where the traffic gonna go, one from the internet provider and other is connected to my MPLS provider. Then if we go on the right side, Omega site, which is here, So here we're gonna run the normal EIGRP process, and we're gonna do EIGRP traffic engineering in this block. So all the EIGRP related stuff, your stub configuration, all that stuff, we're gonna do it on this one. Then in the middle we have a MPLS provider. So MPLS configuration we're gonna do BGP route reflector. Then we're gonna do our OSPF, then BGP bias path selections or path selection process, so attributes and all, we're gonna do it here. Okay, then on the left side we have an internet provider. So there is a protocol known as ISIS, although this protocol is not part of CCIE syllabus, but in production, in real production life, you will find this protocol as well. So I'm gonna tell you the basic of this protocol, and we're gonna configure ISIS, which is similar to like your OSPF. So we're gonna configure it in our internet provider. Okay, then the middle one on the left side here, which is beta site. In this track, we're gonna configure our named EIGRP. So this is a 64-bit mode of EIGRP that we're gonna configure. We're gonna configure EIGRP for V6, that is for IPv6. Okay, so that we are also gonna configure it here. Then on the bottom, we're gonna do all the services like your DSCP, NTP, your syslog, etc. And then we're gonna do automation stuff as well here in this block. Okay, then on the top, I have two sites, which is site phi and site chai. So here we're gonna do DM VPN configuration, where this is gonna be your DM VPN spokes sites. So we're gonna see DM VPN, as well as we're gonna see your IPsec and Flex VPN, which is part of CCIE syllabus. Then on the ETA site, here we're gonna see OSPF for IPv6, which is known as OSPF version 3. And we're gonna run our OSPF for version 4 as well. Okay, and all the OSPF path manipulation and all that stuff, we're gonna configure it here. Okay, so these are some of the major technologies or protocols that we're gonna cover it up, and we're gonna see it in our CCIE topology. Okay, and then if you see it, we have our users that are present, and some of the servers are also present, so that we're gonna configure in a particular VLAN so that they will be able to talk to each other after we configure the complete topology. Okay, so it is a complete topology as per the syllabus, and also the QoS also we're gonna do it here on left side in the beta section. So everything I have covered as per the CCIE blueprint, so nothing is left in the topology, and we're gonna do it on a very advanced level. We're gonna take the scenarios, and we're gonna configure the complete whole lab on the CCIE level for this. Okay, so that's all related to this CCIE Enterprise version 1.0 lab. Okay, thank you. So anyone having any other question related to this? Okay, so there are some questions in the chat. So let me know the fees. So Sheikh, the fees you can, we will provide you the link. So yeah, you can talk to our backend team, and they're gonna provide you the fee structure. No, Ravi, where is SDA? SDA, we're gonna take a different topology that we're gonna put it, because we need to rent the rack for SDA. Then Sridhar, what about ENCOR lab? ENCOR lab, I'm gonna show you tomorrow, the ENCOR topology. Then also what we are doing regarding automation. So automation is present in this lab. Then DM VPN hub location. Okay, so the DM VPN hub will be this router. Okay, so this is gonna be DM VPN hub. Okay, and redistribution, we're gonna do between different protocols. So again, there are some points where we do the redistribution, and between the links which are connected to your service providers, those gonna be eBGP, and in the MPLS we're gonna configure the IBGP. Okay, so I hope everyone is cleared on the lab. Anyone having any other question?
there is no troubleshooting cases here.
Yes, because now in CCIE lab there is no troubleshooting section. Troubleshooting is they remove the troubleshooting section. Okay, but I gonna
Okay.
tell you the real life scenarios in between. What are the issues you can get on a particular configuration as in your real life, and then how you can resolve it. Okay, so in CCIE lab, if I let me just quickly tell you. So CCIE lab exam is now consists of two sections. Okay, so total exam is of 8 hours, which consists of two sections. So one is your design section, which you will get a particular scenario and you need to answer the objective question. So multiple choice, single answer, multiple choice, multiple answer, like that. Okay, so this is gonna be your 2 hour section. And there is a configuration section, which is deploy, scale, and all that, which gonna be 6 hours, and there is a half-hour lunch as well. So again, these are the two sections you need to pass in both the section to clear the lab. Okay, so this is related to the format. So there is no troubleshooting section now. Okay, guys. So anyone having any question before we start with the today topic? So in next 1 or 2 minutes, I can take your question if you have any question on the lab or anything else. After that, I'm gonna start with the topic of today. So everyone clear? I hope you guys able to unmute yourself now. Okay. So today we're gonna start with the spanning tree protocol topic. So let's start with the topic of today. So guys, those who missed yesterday class, I have answered almost all commonly asked questions. So you can watch the recording. You will get a link in our chat, and also you will see on the YouTube as well. So on the YouTube, you will get a recording, and also there's a WhatsApp number present in the chat. So I think the 9 1 is added 2 times. Anyways, it will be sorted out. Yes. So now it will be good. So on this WhatsApp number, you can contact and you will get more details. And still, if you have any question, you can ask, and you can see the yesterday recording as well. Okay, guys. So spanning tree protocol, which is also in short known as STP. So can anyone tell me why we use STP?
Spanning tree is used in order to avoid the loop in our switching network.
Mm-hmm. Okay, and how we create a loop?
Yeah, when we have a redundancy in the network, we can create a loop in our switching environment. To avoid that, the spanning tree blocks some ports.
Yes, so the main reason is we need redundancy, right? Why we need redundancy? Because of failure of device or cable or anything in the network. So we need a redundant things, right? Whether it is a chassis level redundancy, link level redundancy. So when we provide the redundancy, for example, I have one switch, okay, which is connected to two different switch, which are connected to each other. So now if my switch is connected to one switch, so now if you see this topology, there is no loop. But as soon as I create a redundancy, means I create another connection to other switch, then it can form a loop. So if your BPDU or packet goes this way, it can go to this way, and from this way, there this way, this way, this way, it creates a complete loop. Okay, now the problem here is, if you talk about layer 2, there is no TTL field. Okay, so TTL is time to live, which is present in the layer 3 header. So view this loop is indefinite. Okay, so you cannot stop this loop unless until you remove the cable or your switch, any of the switch goes down due to high CPU utilization or memory utilization. Okay, so for that we study, or the persons develop the protocol that we're gonna study, that is known as spanning tree protocol. Okay, so the other causes of creating this loop are your duplex mismatch. So duplex mismatches in the switching environment can also create loops. Your unidirectional link failure. So in fiber, if you see, you have, so if I talk about fiber, so you have two strands in fiber. So one is for your receiving, another is for your transmitting, right? So if one of the strand fails, for example, here it fails, so what gonna send? It gonna sends the BPDU, and this can create a loop. Okay, so unidirectional link also can create a loop. I gonna talk in detail about when we talk about unidirectional. So again, at that time we're gonna do it. Then your physically connected loops, I already told you. So this here, if you see, we have a physically connected loop where I'm connecting the cables to two switches. Okay, some of the software errors can also make a loop. So now once your loops, once you get a loop, then some of the symptoms you can see, like your high link utilization, your high CPU or memory utilization, MAC address flapping, okay, your duplicate unicast frame. So again, these are some of the symptoms which you will encounter. So the solution to avoid this loop is the protocol which is known as STP. And what it gonna do? It gonna block your redundant path. So here, if in above topology, what it gonna do? It gonna make one part, one link as a block link. Again, the link that it gonna be chosen. So there is a algorithm or specific protocol, specific steps that we need to follow so that it can block a link. So again, once it block a link, then it will avoid the loop. Okay, so once it blocked, then your topology gonna look like this. So now the link between these two switches, which is on the right and bottom, is gonna be blocked. So like now the topology will be like this, which you don't have any loop. Okay, so let's talk about how the history of spanning tree and how we gonna evolved from the common spanning tree up to the RSTP or MST. So let's talk about types of spanning tree. So anyone having any question till here? Guys, if you have any question, feel free to ask me in between. I'm not like the other instructors who gonna ask, allow the questions in the last. So if you have any doubt, any question, you can ask me. Okay. So the first is your common spanning tree, which is known as CST, which is also known as 802.1D protocol. Okay, so the main feature of this is, for all the VLANs, you have a single instance of spanning tree. So single instance for all VLANs. Okay, so for if you have 2 or 10 or 15 or 20 or 200 VLANs in your environment or on a particular switch, it's gonna run a single instance for your all VLANs. So now that is the issue, because again it's gonna as the we are increasing on the network and VLANs, so single spanning tree not able to handle for all the VLANs. And the address on the multicast address on which it gonna sends the BPDU is your 0180C2000000. Okay, I am gonna explain you what do you mean by BPDU, so do not worry about that. So this is the first type of spanning tree that we got. After that, the next instance come is PVST. So PVST is the again this is for your per VLAN spanning tree. So now the spanning tree will run for every VLAN. And guys, as soon as you configure the VLAN in your switch, the spanning tree will be automatically enabled for that. So you don't need to put any command to enable the spanning tree instance for a particular VLAN. Okay. So this is, and after that, the third instance with this, which is the better implementation of this, is gonna be PVST plus, which gonna support both of your ISL and .1Q trunk. Okay, so PVST only supports your ISL trunk, but nowadays ISL no one use it. So if you see, we everywhere for trunking we are using the .1Q protocol. So once I take the trunking protocol, I'm gonna talk in more detail about this protocol. Okay, so 802.1Q is the industry standard protocol, which is now adopted everywhere, even on the newer Cisco switches as well. Cisco not supporting the ISL, which is its own proprietary protocol. So now everywhere the protocol support is 802.1Q. Okay, so now here they're gonna support .1Q, and this is on the Cisco multicast address. Okay, so which is 10100 So guys, if you see in common spanning tree, the multicast address is 0180, which is IEEE MAC. Okay, that is reserved for your BPDU. But here, this is reserved for your Cisco, and this is we use here. So again, this is the main difference in terms of when I'm talking about CCIE level of knowledge. You should know when doing the troubleshooting. If you are getting a packet from 0180C200, then that is your IEEE MAC. Otherwise, so again, some protocols which are industry standard, they're gonna run on this multicast MAC, which is 0180C200, and the others one which are Cisco proprietary, they're gonna run on this multicast MAC, which is 0100.0CCC. So again, guys, it is my recommendation that you should aware of these two multicast address, at least as per CCIE point of view. Okay. Again, number of STP. So again, per VLAN we have per STP. So again, if you have 200 VLANs present on a switch, then you will run 200 instance of STP. So every instance will run for every VLAN. Okay. And your BPDU, which is bridge protocol data unit, is going to be sent for each VLAN. So this is related to this. Okay. After that, we got rapid PVST plus, which is rapid per VLAN spanning tree. So again, it has enhancements to your PVST protocol. Okay, what are the enhancements involved? So this topic I'm gonna take it tomorrow. So tomorrow we're gonna see it. And then after that we have MSTP, which is known as multiple spanning tree. So what it gonna do? It gonna solve some of the limitations that we don't have in the PVST plus, okay, or rapid pair spanning VLAN tree. So what the main advantage is, it gonna make your VLANs add to one instance. So for example, if you have a particular VLAN 5, 10, 15, and you have VLANs from 25, 30, 35. For example, these 6 VLANs you are present in your switch. So what it gonna do, for this set of VLAN, you can create one instance of spanning tree, which is, for example, I created one instance 1, and for other set of VLAN, I can create another instance, which is, for example, like instance 2. So now instead of running 6 spanning tree instance, I can run only 2 spanning tree instance, which is instance 1 and instance 2. So it's gonna save the resources on a particular switch. So this is needed, MST is needed where you are dealing with large number of VLANs. Mainly it is used in the service provider environment. So again, but it depends, if you want to run in your enterprise company as well, you can do it. Okay. So again, MSTP, we have a dedicated class for MSTP as well. So I'm gonna talk about that as well. Okay, so if I talk about the protocols related to STP, so IEEE standard and Cisco proprietary. Okay, so here you have CST, here you have RSTP and MSTP, and here you have PVST, PVST plus, and RPVST plus. Okay, so these are the protocols where you have IEEE and where you have Cisco proprietary. And again, out of these two protocols, you will see only these two protocols to be used nowadays everywhere. Okay, so rapid PVST plus or MSTP. So anyone having any question or doubt till here? Those who want to take screenshot, you can take screenshot with me. I am not saving these slides. So if you want, you can take the screenshot. Okay.
Hi, Shank, just one thing. The BPDUs are sent for each VLAN or each switch?
Yes. So for each VLAN, you're going to send the BPDU.
Okay.
Okay. Now, which switch is going to send or which is not going to send, that is a different story. It depends on your protocol. So again, in STP, your root switch will forward it. Then in RSTP, there is some different mechanism. So I'm gonna talk about that. But here, the point is BPDU is sent for each VLAN. Okay.
Okay.
Yep. Okay. So now,
which are the most used protocols here? MSTP and RPVST, is it?
Yes. So RPVST and MSTP. So these are the only two protocols which are going to use. Even in now Cisco switches, you will not see any other support.
Okay.
Okay. So in Catalyst switch, you can see the support of PVST as well. PVST, RSTP, RPVST, and MSTP. But if you talk about Nexus switches, so in Nexus, you will only get the support of RPVST and MSTP. Nothing else. Okay. Okay. So now let's talk about BPDU. So BPDU stands for your Bridge Protocol Data Unit. So basically these are the frames. Okay, so these are at L2 level, which are used to communicate your STP information. So they are helping in making the STP topology. Okay, so they are helping in forwarding the STP information. These are your control planes. So they runs in the control plane. Okay. So I hope everyone knows about what is data plane, control plane, or management plane, right? So the role of BPDU is to elect your root bridge. So root bridge is a bridge which gonna do all the decisions in your topology, and it gonna select your port roles. So again, port roles I gonna talk about in a few minutes. Then if you have any changes in your topology, your BPDU gonna propagate those changes. So propagate topology changes. Okay. Now we have two types of BPDU. So one is your configuration BPDU, which gonna take off your configuration. So whatever configuration change you're gonna do, it's gonna take that one and it's gonna make it to other topology in your complete topology. The other type of BPDU is only generated when you do any topology change. For example, if you add any new device or remove any device. Okay. So it is going to be named as topology change notification. Which is known as TCN in short, TCN BPDU. Okay. So these are the two type of BPDUs which are present. Okay. So this is related to BPDU. After this, let's talk about what is mean by root bridge.
And Shank, all these BPDUs, they run on VLAN 1. Yes.
Sorry?
All these BPDUs, they run on VLAN 1 control plane, or they have
So
their
BPDU is generated for every VLAN, but they're going to share it on the VLAN number 1. So even if you prune the VLAN 1, so if you block VLAN 1 as well, then also they're going to send the control plane information that is not blocked.
Okay.
Okay. So next is your root bridge. So in your complete topology, you have a root bridge is known as your reference point, from where all the STP calculations, all the path cost gonna be calculated from that point. Okay, so in every switching topology, you will get in your enterprise, you will get a root bridge. Okay, so how we gonna elect the root bridge? Okay, so there are rules to elect your root bridge. So first is lowest bridge priority. And guys, here if I'm writing anything as bridge, so take it considered as switch as well. Okay, so root bridge, root switch, root bridge, root switch. Because again, what happens is at the time when STP invented, we have bridges, we not have switches. Okay, so bridges are just the small scaled down version of the switches. So at that time, what they make is they make the algorithms and protocols as per bridge keyword taken in them. Okay, but later on no one changed it. So again, you will find even if you see the show commands which I'm going to show you, so again you will see the same keyword which is known as bridge, but nowadays it is replaced by a switch. Okay, so bridge and switch, although they are not the same thing, they are bridge are scaled down version of switch, so they are not capable of what switch can do. But again, in nowadays, just consider them both as a same thing. Okay, so lowest bridge priority. Okay, so this is a number which gonna start from 0 to 65535. So you can select the bridge priority via one command, which is known as spanning tree VLAN, and then what VLAN 10, and then what is the command. Okay, so let me write the command for you guys. So spanning tree, then whatever is the VLAN number. So again, we're gonna see all these command in the practical. This is just the theoretical topic that I'm taking today. That's why I'm writing it here. Okay, and then priority, and then you need to type the number whatever from 0 to 65535. Okay, by default, every bridge or switch is having a priority of 32768. Okay. And you can increase the priority in the increment of 4096. Okay. So first, for example, the first priority is 0. After that, you need to do 4096, then 8192, like that. Okay. So why we do it in increment of 4096? Again, I'm gonna tell you. So give me 2 minutes. Okay, so this is the first parameter. So lowest bridge priority is considered as a good. So the bridge that you want to make or the switch that you want to make as a root switch, you need to give the lower priority on that. So by default, when you start any of the switch, you will get this priority. But the lower you configure on any of the switch, then that will become the root switch. Now, if you not change any of the priorities, so then, for example, in my topology, these are the 4 switches I have. Okay, and everyone, I not change the priority, so everyone is having the same priority, which is 32768, 32768. So that is the default priority. So now how it gonna select the root bridge? So the second parameter that comes as a tiebreaker is gonna be your lowest MAC address of switch. So whichever switch is having the lowest MAC address, that is gonna be your root bridge. So for example, if my this switch, which is for example 1 2 3 4, so my fourth switch is having the lowest MAC address, so it's gonna be the root bridge for my topology. Okay, so these are the 2 parameters based on what you can elect your root bridge. Now there is a concept known as bridge ID. Okay, which is 8 bytes field. So it consists of bridge priority, which is of 4 bytes, and then extended system ID, which is also known as your VLAN number. Okay, that is of 12 bits. So now if you see what happen is, if it start from here 0 1 2 3 4, so 5 6 7 8 9 10 11 12. Okay, so these 12 bits gonna represent my VLAN number, and then 13 14 15 and 16. Okay, this is gonna represent my priority. Okay, now if I count it into the 2 to the power 0 from here, then 2 to the power 1, sorry, 2 to the power 0, 2 to the power 1, 2 to the power 2. Okay, so whatever is the number, I am taking it into the 2 to the power. Okay, so if I calculate it, it's gonna be 1 2 4 8 16 32 64 128 256 512 1024 2046, and then 2048, and then 4096. So now if you see, the bridge priority field is gonna start, which are on the right hand higher side, which is starts from bit number 13. So 13 14 15 16. So these gonna be reserved or constant by your VLAN number. So now that's why what I was talking about is bridge priority is always in increment of 4096. So now you can relate it here. So whatever is the bridge priority, it will come, the next priority will always come after adding the 4096. Okay, because these are the number of VLANs that you have present. So if I talk about bridge ID, it is a combination of bridge priority and extended system ID. So for example, if I have a VLAN number 10 configured on my switch, so my bridge ID is gonna be, and my bridge priority I have configured 4096 for that. So my bridge ID is gonna be 4096 plus 10, which is 4106. Okay, so in the show command you will see it like that. But anyways, the concept behind bridge priority, why it is increment of 4096, is because it is in the higher topmost 4 bits which start from 13. Okay, so I hope everyone will get that concept. So anyone having any question or doubt in this? All good?
Yeah, hi Shank.
Yes, Jai.
We have something like primary, we can set it as primary and secondary, right?
So
For the,
yes, that I'm gonna talk
so,
about.
okay, okay, thank you.
Mhm. So anyone having any doubt till here? All good, guys? So you can take, if you want, screenshot. Okay. And guys, all these are in the recording, and those who are already enrolled, you will get the recording tomorrow on our portal. So again, you can revisit or check anytime. Okay. So now in our topology, as we love redundancy, so here also in root bridge, we have a concept of primary and secondary. Okay. So the bridge with the lowest priority, with the bridge with the lowest priority will become your primary root bridge, and then you can set one more or two more or whatever you want to configure the second lowest priority on any other bridge, so that in case if your primary goes down, then your secondary can take over and it will become the root bridge. Okay, so for example, if I have these 4 switches, 1 2 3 4, and I want my switch number 1 to be primary and switch number 2 gonna be secondary. Okay, so what I gonna do? So by default, everyone is having the priority of 32768. Okay, so what I can do on switch number 1, I can set the priority via priority command. As for example, I can set 4096, which is, or else the lowest priority is 0. So if you set it 0 also, then it's gonna be lowest one. Okay, so now this will become your primary, and then I gonna set on switch 2, I gonna set my priority of 4096. So this gonna become my secondary. So in case if my primary goes down or got removed from the topology, my secondary gonna become the root bridge. And 4 3 3 and 4 are having the default priority, so they're not going to become the root bridge. In case secondary goes down, then 32768 is both having the same priority. So whoever is the lowest MAC address, that gonna be your this one, your primary switch or your root switch. Okay, now this is the manual way to set the priority, but there is a shortcut command as well, so that it can become the primary and secondary switch. So let me tell you the shortcut command, or you can say it as a macro command. So the switch, for example, I need switch 1 to be the primary switch. So what I can write it here, there's a command known as spanning tree, and then VLAN, and then VLAN number, whatever is the VLAN number for which you need to configure it, and then you can configure root primary. So this is the command will make that switch as a root primary. Okay, so what it gonna do behind the scene? It gonna make your switch priority to 24572. Okay. And then the switch that you want to make as a secondary, you will give the command as spanning tree on that switch, VLAN number, and then root secondary. So that will make that one as a secondary. So what behind the scene it gonna do? It gonna make it priority as 28672. Okay. So now if you're thinking of how these mysterious numbers comes, so 24572. So it will come. So what it do in behind the scenes? So default priority is 32768, right? It gonna take that one and it gonna do the minus of 2 into 4096. Okay. So this is the formula that it gonna apply, and when you calculate this formula, you will get a priority of 24572. And for this one, what it gonna do? It gonna take your 32768 and it gonna minus it via 1 into 4096. So it's gonna do this formula, and after you calculate, you will get this number. Okay. So this is how, if you don't want to set the priority manually, then you can use these commands to make the switch as a root primary or root secondary. So this is the shortcut command, an alternative way. So these are the only two ways via which you can set any root bridge as a primary and secondary. Okay. So anyone having any question or doubt till here?
Yes, hi Shank.
Yes.
In our case, in which case we must put the primary say the core switch or the distribution switch.
Okay, so if we talk about the switch, so again in the primary switch we need to use for the distribution only, because again after distribution what I recommend is you should use L3 adjacencies. Okay, so you not this is not an ideal practice to run switching in the core. Okay.
Okay.
So design point of view, you should use distribution switch. So one distribution switch as a primary and another distribution switch as a secondary.
As a secondary, yes.
Yes, and there are some other mechanisms that you need to follow, like your root guard and all that stuff, which I'm gonna tell you in future class, that you should enable so that none of your access switch can become root. We don't want our access switch to become root, because
Yes.
if you make access switch as a root, then all your traffic will go via access switch, and access switch is usually not a high-end switches, right?
Yeah, right. Yeah.
So again, that scenario I'm gonna talk about later on.
And which is the best way? Is it automatic or manual spanning tree VLAN root primary per VLAN? Same better way or manually better way?
So again, manually is used wherever you used. If you use priority command anywhere in your environment, then better is to use manually. Okay. Otherwise, if you not change the priority till yet, then you can use this root primary and secondary. Because for example, if I have one switch where I have manually configured 4096 as a priority, then this command will not take effect, because again this will make the priority as 24572 and that priority will not make that switch as a primary switch.
Oh yes.
Okay, so if you not configured anywhere as a priority command, then it is okay, otherwise you can use this one.
Okay.
Okay, so more granular is your priority command. Yes.
Quick question, Shank. When you say all the traffic goes via root bridge, is it the control plane traffic you're talking about, or the data as well?
So there are some scenarios where data plane traffic can also go via that as well, which I'm gonna talk about when we do the HSRP and all. So in that case, the primary switch will take over the traffic, because HSRP we configure normally wherever, whatever is the primary, we're gonna configure that as a HSRP primary as well. So again, and in access layer, if someone added the switch and it will make it as a root, so that is also a security threat for your environment.
Yes.
Okay, so there are some scenarios it can disturb your whole topology. So we're gonna talk about those scenarios.
Thank you.
Okay. So anyone having any other question? Okay. So in spanning tree, guys, lower is it works on the path cost, and the path cost parameter is lower is better. Okay, so whichever is the shortest path, it's gonna take. So again, your port role is gonna be selected based on that. So again, what are port roles? I'm gonna talk about them, but let's first discuss about what is path cost. So path cost depends on your link speed. Okay, and there are two models that are present, which is short cost, which is your old model, and you have your long cost, which is your new model. So now what's gonna happen is, way back in 90s, we have 10 Mbps links, then we evolved from 10 to 100, then 1 Gbps, 10 Gbps, 20 Gbps and above, right? So previously till 2005, we are good with the short cost method. Okay, but after that we got issues. Now let me tell you what are the issues. So again, for 100 Mbps, so again, path cost lower is better. Okay, so for 10 Mbps the cost is 100. For 100 Mbps the cost is 19. 1 Gbps is 4, then 2, then 1, and then the problem starts after 20 Gbps. So previously we don't have the links above 20 Gbps, but nowadays what we have 40 Gbps, we have 100 Gbps, we have 400 Gbps as well, right? And 40 Gbps is so common in data center. Nowadays data centers have 40 Gbps uplinks, mostly 99% of cases. So this cost will become 111 after that. So if we use short cost method, then if I put 40 Gbps or if I put 100 Gbps, spanning tree gonna treat both the link as the same. Okay, so instead of sending traffic to 100 Gbps, it's gonna send the traffic to 40 Gbps. Okay, so this is gonna be problem. So that's why they created a new addition of the new path cost in the protocol, and now the cost will become like this. So for 10 Mbps, this is gonna be 1, 2, 3, 4, 5, 6. Okay, so 20 million, I think. Yeah, so 20 million. Then this is gonna be this one, then this one, then 10 Gbps is gonna be 2000. 20 Gbps is gonna be 1000. 40 Gbps is gonna be 500. Okay, then this is gonna be 200, and like that way. So 20, 40, like that. Okay, so it's gonna manual.
I think second and third are same.
Sorry.
Yeah, doesn't mean I miss 10 in 100 megabit per second here in 2.
Okay, so 1, 2, 3, 4, 5. Here it is 5, 6. Okay,
In
now
the first one should be 20 million, right?
right.
I think it is
20
2 million,
million,
right?
or yeah, it is 2 million, not 20 million.
Okay.
Okay, so these are 6 zeros. After that, we have 5 zeros, 4 zeros, 3 zeros, and like that way. So to increase the cost above 40 Gbps, 20 Gbps, we have a long cost method. So again, there is a command, like in old switches, still the default is short cost. So there is a command which gonna enable your long cost. Okay, the command is spanning tree path cost method, and then you have long/short. Okay, and MSTP by default will use long cost method. Okay, so this is related to this. So now after this, let's talk about port states. So in STP, when you enable or disable the links, so again, it's gonna go with the different port state. It is not like STP will block its link automatically. You have different states through which it goes, and then it's gonna do the calculations and all that stuff, and it's gonna decide what to do and what not to do. Okay, so let me talk about spanning tree port states. So the number one is disabled. In some books, you will not find this state, but again, what I used to do is I consider this as a state. So this is the state where you have admin down, okay, shutdown command present, or your cable is not connected. Okay, so no frame is forwarded. Okay, do not participate in STP. Okay, do not send receive, does not send receive BPDU. Then after disable, there is a blocking state where you have no user data, no BPDU, no sending of BPDU. Okay, but it can receive BPDU. So, and even that is a compulsory requirement to receive the BPDU. I will talk about that later on. If it not receive the BPDU, it gonna remove itself from blocking. Okay, because BPDU is gonna tell to the particular port that you should be in the blocking. Okay, do not unblock yourself. So it needs a constant BPDU that gonna tell you don't need to unblock yourself. We have a better path through other what I can say, other cable. So do not block yourself. Do not unblock yourself. Okay. Then you have a, so here the blocking, if it goes from blocking to a next state, then there is a delay which is known as blocking delay, which is of 20 seconds. Okay, so after blocking, it's gonna go to your listening state. So in listening also, there is no user data, but it can send and receive BPDU. Okay, and no MAC address landing. And there is a delay in that state, which is known as forwarding delay. And it is of 15 seconds. Okay, after it passed the 15 seconds, then it goes to the learning state, where it start learning MAC address. And it's gonna send and receive BPDU. And again, there is a delay, so there is no still user data here as well. So no user data is sent or received. Okay, then there is a forwarding delay in that stage as well. So total forwarding delay is of 30 seconds. So here also 15 seconds. So 15 seconds in listening and 15 seconds in learning. So total forwarding delay is of 30 seconds. And after this one, it goes to the final state, which is known as forwarding state, where you have data traffic flows. Okay. So if you do from blocking to forwarding, then it's gonna take 30 seconds. Okay, and for blocking to listening, it's gonna take 20 seconds before it doing the, if it's not getting the BPDU, then it unblock itself to the 20 seconds. Okay, so total 50 seconds you will take from for blocking to forwarding, and 30 seconds if it is in listening. So again, from listening to learning, then forwarding, it's gonna take 30 seconds. Again, these forwarding delay timers, okay, you can change it if you want. There is a command to change these timers, but ideally it is not a good practice to change it. But again, there is a range, I guess, from 2 to 30 seconds. There is a range by which you can choose and you can change these timers. Okay, so this is related to port states. Now let's talk about port roles. So one is your root port. So root port only exists on non-root bridge. Okay. So the bridge which is not, or the switch which is not root, is having the root port. So what it do, it is lowest cost to get to root. So for example, this is my root, okay, and this is my switch number 2. So I need to decide the root port on my switch number 2. Okay, and for example, the cost of the links everywhere is 10. So this is just the example I am taking. Okay, so now from my switch number 2 reach to root, there are 2 ways. Okay, so this is your first way, and the other way is through switch number 3. So this is my second way. So the cost through yellow one is 10, right? And the cost through red one is 10 plus 10, 10 here, 10 here, which is 20. Okay. So now what it's gonna take, it's gonna do the link which is connected with the lowest cost. It's gonna make it as a root port. So this port is gonna be your RP, which is known as root port. So if you do the show spanning tree command, which I'm gonna show you in the practical, so it's gonna port. So for example, if this is E1 by 1, so it's gonna show this port as a root port. Okay. So this is the first type of port that we have in STP. And your root port will learn MAC address, and it gonna receive BPDU as well. So root bridge gonna send the BPDU towards your root port. Okay. Next port is your designated port. So this port exists on both root switch as well as non-root. Okay. So now for root, every port is designated port. So you can close your eyes and you can mark that as designated port, which is known as DP. Okay. So for root, every port which is connected to root bridge is your designated port. Now for non-root, we have a mechanism to identify the DP port, which I'm gonna talk about in some time. So what I told you, all ports on root bridge are designated port, which is known as DP. What it can do, it can learn MAC address, it can send and receive traffic. Okay, it can transmit BPDU, and it is always forwarding. Okay, so this is the role of designated port. Then the third port is gonna be your non-designated port. So ports are non-designated ports are, which is known as NDP, are blocking ports, which gonna break the loop in your topology. Okay, so how do we decide that? I'm gonna tell you. So these will not forward any user traffic. No MAC address gonna learn on these ports. Okay, and they can receive BPDU. Even this is a compulsory requirement. If they stop receiving BPDU, then they're gonna make itself to the designated after 20 seconds. Okay, so that is related to non-designated port. So now let's see how we're gonna decide these 3 ports in a particular topology. So again, once you configure a VLAN in your switch, your spanning tree start automatically and it gonna do all the calculation automatically. You don't need to do anything, but behind the scenes how it do it, let me tell you. Okay, so I have a topology with switch 1, switch 2, switch 3 and switch 4. So let's first understand via simple topology. So first of all, you need to decide the root switch in it. Okay, so by default, the priorities are 3 to 7, 6, 8. If you change the priority, you can make any switch. Otherwise, whatever is the lowest MAC address, that is gonna be your root switch. So let's think, or let's take it this switch as my root switch. Okay, so based on the MAC address, for example, the MAC here is 1111.1111.1111, and here the MAC is 2222. Here the MAC is 3333. So this is just the example I'm taking. Okay, and here the MAC address is 44444444 and 4444. So now based on the MAC address, my switch 1 will become the root switch. So automatically whatever the ports that are on switch 1 is gonna be DP. Okay, so you can write it DP automatically. Now let's assume the path cost between each of the switch is 10. So this is just the assumption I am taking. Okay, so now if you see switch number 4, so switch number 4 to reach switch 1, you have 2 ways. Either switch 4 to switch 1, which is having the path cost of 10. The other way is switch 4 to switch 3 to switch 2 to switch 1, which is having the total cost of 10 plus 10 plus 10. It is gonna be 30. So the less cost is from switch 4 to switch 1. So it's gonna make that port as a root port. Okay, so first of all, we need to decide root port on every switch. So my switch 4 root port is decided. Similar way, if you see switch 2, so it is that directly connected is gonna be 10. The other way is 30. So it's gonna make this port as a root port. Similar way, we need to decide for switch 3. Now see it here. The problem here is both the way you will see the cost of 20 and 20. So from switch 3 you have 2 paths. One is via switch 4, another is via switch 2. So from via switch 2 there is a cost of 20, and then via switch 4 there is a cost of 20. Okay, so this is a tie. So to break the tie, there is a parameter known as, so the first one is going to be lower cost path. But now here this is a tie in the cost path. So the second parameter is going to be lowest sender bridge ID. So bridge ID is a combination of your priority plus VLAN and plus your MAC address. So right now, if you see, so priority is same for every switch. VLAN is also same for every switch. Okay, means we are doing it for a particular VLAN. So now the third component is MAC address. So whoever is the lowest sender bridge ID or lowest sender MAC address, so there that side it's gonna take the root port. So from switch 3 point of view, the switch 2 MAC address is 2222 and the switch 4 MAC address is gonna be 4444. So lower is switch 2. So the port which is facing towards switch 2 is gonna become your root port. Okay. So this way it's gonna select. But again, if you got a tie in this as well, then the third parameter also come, which is your lowest sender port ID. So if example, instead of these 2222, if both sides it is of 2222, so then whoever is the sender lowest port number. So for example, here it is 0/1 and here it is 0/2. So whoever is the lowest port number, it's gonna select on that side as a root port. Okay, but here we done the tiebreaker on the second point only. So if that is same, then the third condition will come. Okay, so now we decided the root port on each of the switch. Okay, so now the port which is in front of your root port is automatically become the designated port because it needs to send the packet towards the root bridge. So the port which is opposite of your root port is always designated port. Okay, it can never be in the blocking state. So always remember it. Okay, so if you see here it is root port, so this one is designated. Here it is root port, so this one is designated. Here it is root port, so this will become your designated. Now we need to decide on between switch 3 and switch 4 where on which side we need to block the port, because that if you see this is a loop in our topology. So to break the loop, STP need to block one side. Okay, so now which side STP gonna block? So again, it gonna be your same algorithm that we have made it here. So you need to do it same way. So what is my recommendation is you will take the middle point and then you try to figure it out. So if from this middle point I go till here, so the path cost is 10. Okay, so middle point means till here to here I am taking the path cost as 5 and here to here I am taking the path cost as 5. So from here the path cost is 5 plus 10, which is 15, and from here the path cost is 5 plus 10 plus 10, which is 25. So this route is longer on the right side. So this one is longer route and this one is shorter. Okay, so the shorter side is gonna be your DP designated port and the longer side is gonna be block 1. So it's gonna make this port as a block port. So this way you're gonna select block port. So there are some things that you always need to remember. First thing is on your root switch, all the ports are DP. If you see the links between your switches, one side you always find DP port. Okay, so every link between your switches is having a DP port for sure. Okay, and then other side can be root port or it can be blocking. Okay, so anyone having any question or doubt till here? So this is the mechanism via which they calculate it. So again, in interviews, interviewer can ask you how you calculate or how you make the DP and root port, or else in the troubleshooting also you can check it out. Otherwise, this calculation STP will do automatically for you. So you don't need to worry about that. Okay. Now this port cost, which I wrote as 10, you can change this port cost as well if you want to do any traffic manipulation. Okay, for example, you don't want traffic from switch 4 to switch 1 to go directly. You want it to go via switch 3 and switch 2. So what you will do? Can anyone tell me what cost I should write?
Yeah, I can change the cost on R4, for example. If I want the traffic to go through switch 4 to switch 3, I can change the cost. For example, here it's 10. I can make it lower.
So if you make it lower, then it's gonna choose that path. Lower is better in STP.
Oh, okay. Oh, yeah, to change, I'll make it higher. I can make it.
So how much higher I need it in this topology if I am taking?
For example, here I can make it 20 or more than here. If I do, for example, instead of is 25 here, I can make it 30, for example.
Yes, so even on 30 as well, it's gonna take it that path because switch 1 is having the lower MAC. So you need to make the cost above 30. That means you need to take it 31 and above.
Oh, okay.
Okay, because if you take 30, for example, you take instead of 10, you take this one as 30. So now via this path, it is 30, and via this part also it is 30. So your first gonna be tie. So then it's gonna take the lowest sender bridge ID. So here the switch 1 is having the lower bridge ID as compared to switch 3. So switch 4 will take this port as a root port again. Okay. So to make the traffic path, need to change it. So again, this type of questions you will get in CCIE, where they need to make it traffic manipulation based on the topology. Okay. So this is how you should know the backend mechanism of how it works.
We can also know the cost from switch 4, and from switch 1 to go to switch 4. And
yes.
Switch
So again, you can do a lot of things here. So it depends. There is also one more parameter which is known as port priority. If port cost not make it any difference, then you can do it based on port priority. Faraz, can you make your mic mute? Thank you. Okay, so
Shank, this bridge ID, is it priority plus
MAC address.
okay, priority plus VLAN plus
See,
MAC address, or only priority
yes.
plus VLAN?
So again, it is not plus here. So it is actually the two conditions. First, it checks priority plus VLAN. Okay, so VLAN is gonna be always same. For example, if we are talking here about this topology, then it is for a particular VLAN, because spanning tree gonna calculate the things as per VLAN, right? So even if you can skip this one, but actual formula is priority plus VLAN, but VLAN is gonna be same, right? So first is it gonna check the priority. So whoever is the lowest priority, but in our case, if you see, we have a default priority, we not change the priority. So then it's gonna check the lowest MAC address. Okay. So anyone having any other question or doubt?
Yeah, hi, Shan.
Hmm.
Just a quick question. Spanning tree usually to avoid the redundant loops, right?
So to avoid the loops, basically not redundant loop. Due to redundancy, we can get a loop.
Yeah. My question is like, for example, how about the data traffic flow? It still has to go to the root, right?
So again,
I mean,
it depends on, so route is gonna make for the control traffic, okay, but your data traffic is go as per your other mechanisms as well, like HSRP if you configure. So basically, switch gonna send the data towards the default gateway, right? So for
yes.
example, here if I talk about, this is my distribution switch. So DW1, DW2, and this is for my access switch. Access 1, access 2. Okay.
Yeah.
And this here I can make HSRP primary. Okay. And then this will, I will make HSRP secondary for VLAN number 10. Okay.
Yeah, that is understandable. But what I mean to say is between, I mean, if I want to route it outside or something, I need to reach to the gateway. Like for example, from this example point of view, that's fine. Like example, if I'm talking about the spine leaf structure or something, Or
So
I mean,
Spanleaf is having a different type of topology. They have
sorry,
a L3 links.
yes,
So that
no,
is completely different.
yeah, I mean to say, like, for example, if you're talking about the tier 3 or a tier 2, where I have distribution switches, two distribution switches and access layer switches in each floors, and I have redundant links between all the access layer switches to both the distribution switch.
So this way.
So yeah. So in this case, I will not have a connection between access layer switches.
Okay.
So it's mainly terminating on distribution switches. So in this case, even the layer 2 data traffic has to pass to the distribution, and it has to.
So in this case, whatever a layer 2 will make doesn't matter. Whatever is your HSRP primary device, your traffic will go via that way.
Okay, again, the HSRP is again, you're talking about layer 3. I mean, I need to go to a different VLAN, or I need to point to the internet, or I mean, exit route. I mean, talking about that, like VLAN 10 in access layer switch 1 and a device in the same VLAN, but in access layer 2 switch. So that traffic still has to go via the distribution switch only, right?
Yes. Because again, you don't have any link between access layer switch, right?
Access layer switch, yes.
Even
So
if you make a link between access layer switch, it can go directly.
yeah, it will go directly, but
right?
usually
But if you don't have any link, so your traffic will go via switch, this one. And then in that case also, there are two mechanisms that take place. One is your active standby. Your server is connected to active standby, or it is connected to active. So if it is in active standby, so whatever is the active port or adapter which is connected to which distribution switch, it goes via that one.
Okay.
Okay, and in case of active, you need to make it your both distribution switch into the VSS. And then you need to do active NIC teaming on your server.
Okay, this is if you're talking about the servers. I mean, like for example, a end device like a mobile or
so
laptop.
mobile and laptop, so these are all active standby. Even they don't have the other gateway, right? So they have only one gateway which is present on them. So in that case only, whatever it's gonna take via your distribution switch only.
Okay. Yeah.
Okay.
Okay.
And the other recommendation is you not span your VLAN on large number of switches. That's why there is a concept of end-to-end VLAN and local VLAN. So better to have a local VLAN in your environment, which is spanned up to the distribution switch only, or maximum 2 access layer switch. So again, if you don't need L2 migration things or Oracle clustering or database clustering, synchronization, backup replication, then do not span your VLANs on different switch. Okay, it is not a good or recommended practice.
No,
So
for
mainly,
yeah, what I mean to say is, like for example, from a perspective of not an enterprise perspective, like at a corporate office or something, like if you are thinking about an hospitality sector, like for an hotel, which has like 20-25 floors, and each floor is having a separate access layer switch, and each floor is having like 20 rooms, and each floor is like for first floor 100 and start from 101 till 120. So these needs to have wireless VLANs will work on a
yes.
single
So
VLAN.
again,
That's fine.
I gonna make it that star. So 90% of where we need to span our VLANs is where we are using wireless, because then you need an end-to-end roaming, right?
Yes.
You don't
So
want
in
your
that sense, it's okay.
connectivity
It's
to,
like
yes,
one VLAN roaming.
yes. So
Yeah.
again, in wireless, you don't need, like when you are coming from one floor to another, you are breaking your connection every time.
No, yeah, that is understood. What I mean to say is, like, for example, the guest will bring their wired device also. I mean, for example, laptop, they don't want to use wireless, so they will plug in. So in the hospitality, what they do is like for each room, they configure a separate VLAN. So when you're doing a billing system, you will be recognizable, like you're coming from this room, from this VLAN. So the billing doesn't get mixed up to other room or something. In that case, so it will be each VLAN for each room, like 200 rooms property will have like 200 VLANs. So it has to go from like access layer switches connecting directly to the distribution switch. So in that sense, I was asking.
Yes. So the
Yeah.
only thing is that is what I'm talking about. You need end-to-end VLANs where you don't want to break your connectivity, right? Otherwise, you don't need an end-to-end VLANs, or you need end-to-end VLANs in case if you are doing any vMotion type of stuff.
Okay.
So that in, for example, in one data center and you have a virtual machine sitting in another data center, you will shut down the virtual machine here and you will bring it up there. So there you need end-to-end. Otherwise, the second other option is over layer 3, you need to create a layer 2 overlay. So that you can do either via VXLAN or any other tunneling mechanism.
Okay.
Yep.
Okay. Thank you.
Okay. So, okay guys. So now I have 2 more topics left. So let's quickly do it. So we have a timers. So the timer is, first one is hello. So it's gonna send every,
Excuse me?
yes.
You were talking about port priority, but I don't think you where it fits in the last path selection we were talking. Could you repeat that?
Yes. Okay. So port priority, I think we left it, right? So after port cost, there is another concept of port priority as well. So for example, in the last topology, let me see if I can make it. Okay. So in this last topology, if I say to you, do not change port cost. Okay. You are not allowed to change port cost or this costing anywhere. Then how you can make your switch 4 to go traffic via switch 3, switch 2, switch 1. So there is another parameter which is present, which is known as port priority. Okay. And it is in increment of 16. By default value is 128 of every port. Okay. And lower is better. So in my last topology, the way where the switch 4 which is connected to switch 3, I can go to that port and I can change my port priority on that port. Okay, so that my control plane traffic or whatever traffic I need to send, it can go via switch 3. Okay, so if you're not allowed to do changes in port cost, then you can do the changes based on port priority, which we're gonna see in the practical. Okay, so we have a practical related to this. And it is only significant between your local link, for example, between 2 devices only. Okay, so this is the only significance. After this link, it's not gonna have any other significance. Okay, so this is related to port priority. Now we have timers. So here the first timer is hello time, which is 2 seconds. So this is the time where root bridge is gonna send configuration BPDU. So every 2 seconds it's gonna send the configuration BPDU to check if any of the configuration changed or the topology is in sync or not. Okay, so range is from 1 to 10. You can set it from 1 to 10, whatever you like. Command in the global mode, spanning tree, VLAN 1, whatever is the VLAN number, and then hello time and whatever time you need to set from 1 to 10. Okay. And second one is max age. So max age is gonna be 20 seconds. So it will tell how long it gonna wait in blocking state. So if it stop receiving BPDU, it gonna wait for 20 seconds. After that, it gonna make itself in a forwarding state, like in a listening, and then after listening it goes to the learning and then forwarding. So again, this timer is configurable. You can change it. The command is again spanning tree VLAN, whatever is the number, and then max age, and then whatever is the range. I guess it is from 1 to 20. Okay, I'm not sure on the range, but again, it is from 1 to 20, I think. Okay, then forwarding delay. So forwarding delay is the timer which you spend in the listening and learning state. Okay, so by default in every state it takes 15 seconds. So 15 seconds in your listening and 15 seconds it take in your learning. So you can change this timer as well. Again, the same command, spanning tree, VLAN number, and then the forwarding time. So this way you can change these timers, but again, it is not recommended to change the default timers. So there is another way which is we used to use in CCIE, which is known as network diameter. So these timers are optimized, taking in mind that your switching environment is end-to-end optimized for 7 switches. So for example, they are taking in between, you have 5 switches. Okay, so this is optimized for that way. So they are taking like your topology is having the switching environment is consist of end-to-end having the 7 switches. Again, this is little old because nowadays you will get more switches in between, but timers are optimized in that way. So again, this is the default, but you can change your timers by changing the diameter. Okay, so there is a command which is known as spanning tree VLAN ID, whatever is the VLAN ID, and then root, whatever you need to select, primary or secondary, and then diameter, and then whatever you need to select, the range. Okay, so via that command you can change the diameter, and according to that your timers are automatically changed, which are optimized for that level of topology. But again, to be really frank with you guys, in my 12-13 years of career, I never seen anywhere where anyone change it via diameter, or even I didn't see the timers that are changed. Okay, so again, but if you need it, so these are the two ways to change the timers, either via diameter or via timers direct commands. Okay, so this is related to your timers. Okay, so anyone having any question or doubt till here?
Yeah, Shank. For MSTP, right? It's based on instances, as you
Yes.
told. So is the command going to change because this is per
Yes.
VLAN you're setting?
Yes. So MSTP is having a whole set of different commands. There is a
Okay.
spanning tree mode. First of all, you need to set, and then you need to go in the MSTP configuration mode. So the command is start from MSTP, so spanning tree, MSTP configuration, and then you will add whatever commands you need to type. You need to type in that configuration mode.
That
So
mode.
the
Okay.
commands are definitely changed. So tomorrow I'm gonna take the RSTP and MSTP topic related to that. Okay. So okay, that's all I need to teach today only. So guys, again, this is the last class for free enrollments. Those who not enrolled it yet, you can enroll it. The link is present in the chat. You can talk on the WhatsApp. Let me paste contact information here on screen as well for you guys, because from tomorrow the class is locked. Okay, so those who are enrolled, they will be only able to join. So you can enroll on this email ID. You can email or direct chat. You can do it on this WhatsApp number. Okay, you can take a screenshot of this one so that it will be handy for you. And like it is a, as you know, it is a combo CCNP, CC SD-WAN and CCI batch. Okay, and all the three I am taking only. So if you like my teaching style, or if you like my knowledge, then you can enroll it. Okay, so still we have 5 minutes left. So if anyone having any question or doubt, you can ask me. So I already explained what is CCIE, how our topology, how we're gonna do our workbooks and all that stuff. Anyone having any question, doubt before we wrap up for today's session?
Yes, I wanted to ask, are you covering these protocols, BGP, OSPF, version 3, all of them, or no, in your labs?
So, not Faraz, I'm not getting your question. What you're saying?
I'm saying, are you covering protocols, CCIE, OSPF, and BGP for labs?
Yes, everything.
Okay.
So if you see CCIE lab blueprint or CCIE enterprise labs syllabus. Okay, so as per the blueprint, I will go. So whatever the exam topics we have, I'm gonna make the lab on those topics.
I see.
Okay, so here you have complete switching, routing, EIGRP, OSPF version 2, version 3, BGP, multicast. Then SDXs, we're gonna take a different lab. Then SD-WAN, we have a complete own lab. Even in this course, if you enroll for CCI, we are giving you SD-WAN complete module, which is much more than this. So I have a dedicated class for SD-WAN, okay, which covers the complete SD-WAN. So this is just a 25% of SD-WAN, which you have in CCI, but I'm gonna take it up to a very advanced level. Then MPLS, we're gonna take DMVPN, then security stuff, quality of service, and then services, then automation and programmability. So these all, whatever the topics present in CCI, I'm gonna take it on the lab.
And for these labs, you said you're using EVNG and PNet. Are you providing the templates, or we like design the lab ourselves?
So again, if you see in the beginning of today, I have shown you the topology. This is our topology for the lab. Okay, this is already, we made it on the PNet, and we're gonna, if you want, we're gonna provide you the UNL file. If you want, we have our lab instructor as well. Okay, dedicated lab instructor that gonna help you as well. Okay, the minimum requirement is 32 GB of RAM and 6 core of CPU.
That's fine.
Okay, and there's a question which is, are you repeat this concept again after locking the class? So Anish, there are two timings for this batch. One is from Monday to Thursday, 9 p.m. to 11 p.m. The other timing is Saturday, Sunday, 9 a.m. to 12 p.m. Okay, 12 p.m. right. So in Saturday, Sunday in the morning time, I'm gonna again repeat the same concepts, but the advanced level scenarios that we are doing on Saturday and Sunday in the night, which is from 9 p.m. to 12 a.m. So that class is not repeated. Okay. So guys, today is the last day for enrollment because from tomorrow the class is locked. And again, these are not demo classes. This is the live, what I can say, the how I teach in the class. So the same way I taught you for past 2 days. Okay. So these are nothing to do with demo and anything. So again, not gonna wait for anyone. We're gonna take covering the concepts and syllabus.
I think I already.
Shank, I had a question.
Yes.
I have enrolled for the ENCOR training, and there must be some difference between the CCI lab topics and ENCOR topics, right? ENCOR might be having some other topics like automation or wireless. Will
so
that
again,
be also covered?
Yes. So again, if you talk about ENCOR and RC, there is only some topics that like wireless automation is also covered in CCI. So SDA is on the very basic level in ENCOR. It is like 30 to 40 minutes of topic in ENCOR. Okay. So if you see, automation is also present in CCI. But only the topic that is not present in CCI is the wireless. Okay. Which is 1 day class only. So apart from that, every other topic is covered in CCIE as well.
Okay.
But if you are only enrolled for ENCOR and an RC, then you miss a lot of advanced topics for CCIE that I want to take.
Okay.
And I think I already enrolled for this class. I think I enrolled day before yesterday when the first class started. So is that the enrollment? Because I enrolled via LinkedIn. I saw the link. I registered. So I think, is that the enrollment, or the enrollment is a different one?
So enrollment means you have paid the fees of the classes that I'm gonna take, right? Yes. So this is just the 2-day class for free that you're going to see how I'm gonna teach, right? So after that, from tomorrow onwards, it's gonna be logged. So enrollment means here is those who paid for the course that we have.
Yeah, in other words, the enrollment is like you get a username and password in the website so that you can log in and review the footage and videos and everything later on as well.
Yeah, so all the workbooks, all the what you can say recordings, all that stuff gonna be uploaded for you guys, and you need to do the practice, and you can see it anytime you want. So after this, there is no free class, and there is no YouTube streaming like that. Okay, so this is what we have done for 2 days only. Okay, so anyone having any other question before we wrap up? Okay. So thank you everyone for joining today. So I hope to meet you all from tomorrow onwards, where we have a lot class. So you will get only the persons who paid the fees for the course will get it. Okay. And again, guys, in our CCIE complete and enterprise, you will get CCNP and core and RC and SD-WAN free of cost. Okay. So thank you everyone for joining. Let's meet it again tomorrow. Thank you.
Thank you, Shang. It was very informative.
Yes, thank you, Sean. Bye tomorrow.
Yeah, bye. Thank you.